On my blog and on my Kicad YouTube channel, I've gotten a number of questions about how did I learn how to do this Python scripting stuff in Kicad, and what happens if a function that I need to be exposed in Python isn't there. How do I go about exposing it? So in this video, I'm going to walk through a change that I recently submitted to the Kicad team to expose some existing functionality that wasn't available through Python. I figured that walking through some code and then talking about the context of that code would be helpful to some that want to know more about the innards of Kicad. A little bit of context of what the change is. In order to do one of my plugins for converting DXF files to mounting holes, I need to be able to know what footprints are available. In the process of doing that, I ended up kind of with this module selector. It's similar to what you get. Well, it's similar information to what you get when you click the add footprint or when you're in the footprint editor. But that stuff isn't available in Python, and I needed lists of libraries and footprints anyway. So I threw together a quick little WX thing to be able to do that. So here I can click through the different libraries and it shows me the footprints that are available. But as I said, in the current Kicad, I'm not aware of a way to get to this information from Python. So let's look a little bit at the part of the code that enumerates through these footprints and libraries, and then I'll show the change that I needed to make in order to make those APIs available. So the code is really pretty simple. I have here a API called pcbnew get logical libs. Call it here. It gives me a list of all of the libraries that are available. Mounting hole is the one that I need for my particular plugin, but of course there's all the other ones that you have installed. The other interesting API that I used for the picker is once I have a library name, I need to then convert it to a list of, once I have library name, I need to convert it to a list of modules. So that happens when I click on the lib button saying, hey, I want this new lib, and set lib here. So pcbnew footprints in lib, which takes a string, which is the name of the library. Let's demonstrate that here. Do that, and then take our mounting hole. And here we have a list of all the mounting holes, footprints that we have available. Additionally, I also added pcbnew get footprint or footprint info. Footprint info, as it shows here in the help message, it takes the name of a library, colon, and then the name of the footprint. So let's try that. So we happen to be in the mounting hole library, colon, and then we will just randomly pick one of these, that. And when you do that, it gives you some information about the footprint. In most cases, you probably don't need this, but it was available, so I added it. So it's got one pad in this case. It's got the name, it's got some keywords, things like that. Those are useful like in PCB when you're filtering for different criteria. So how did I expose those particular APIs? Here I am in my particular Kicad checkout. If I do git diff tool, I will then get my handy dandy beyond compare diff tool. I highly recommend beyond compare. The order of the files that I'll be showing you is purely based on the order that Git gives them to me. So hopefully that won't be too confusing. So the first change that is made is in the cmake lists. It's in the pcbnew cmake lists.txt file. In this case, because I am adding to the swig area, here I am adding to the dependencies of pcbnew _ wrap. That's where the C++ code for the Python to C++ translation happens. It's a fairly large file. It can be helpful to be familiar with that file though. So the make file needs to know what depends on what. So here I'm telling it that I want you to also depend on this autodoc.i file, as well as this swig typemaps file that's a new file for this particular patch. If you don't add this, then when you do make, after changing one of these two files, then it won't know to re-swig to generate this thing, and confusion ensues. All right, so next file, footprint.i. This is an interesting file. So here you have to update the copyright notice since it hasn't been changed this year yet. So that's something that if you want to make a patch for Kicad, you will need to do that. Here are some additional files that the C++ code of this translation unit will need coming down here. So the first really interesting part of this file is this inline block. In Swig with inline, what you're telling Swig is, first, I want you to find each of the function signatures, and I want you to create a translation between this C++ function and the Python world so that I can call this function from Python. In this case, I take a WX string, which is automatically converted from a regular Python string, and it returns a WX array of strings, which will automatically be converted into a list of Python strings. How this particular translation here happens, I will show you in a separate file when we get to that. In this case, I have the name of a library, and I want to return each of the footprints that exist in it. So first thing I need to do is get a PCB edit frame. PCB edit frame is a very important class in pcbnew and Kicad in general. Here we have the Doxygen output on the Kicad website. Each of these levels here have interesting APIs. Anybody that wants to understand anything about C++ part of pcbnew really needs to be a little bit familiar with this class. There are many, many methods, and I am not saying you should read through all of the code. You should at least look at the method names and kind of get a feel for what this thing does. There's a lot of user interface type stuff. So responding and dispatching key presses, responding to left click, right clicks, things like that, all go through pcbnew. If you're trying to understand how a command works, chances are you're going to be in a file that contains PCB edit frame methods. Unfortunately, those methods are not all in one file. They are probably spread around about 20-30 files. So you have to do a lot of time searching with grep or awk or ACK or something like that. So I have an edit frame. I then ask for the project. Project, I believe, is how communication between EE Schema, Kicad application itself, pcbnew, communicate with each other for things like maintaining library lists, settings for look and feel, things like that. So here I ask for a fplibtable. Fplibtable here is basically going to be a file that looks like this. It is in your local personal config area. I'm on Linux, so it's going to be in .config in Kicad. On Windows and Mac, it'll be somewhere else. This is what gets changed when you add a library to your global tables. So we have this fplibtable, and so then I'm going to call this thing here saying, hey, can you enumerate through all of the footprints, return it into this reference, and I want you to filter by the library name. Now that I have the footprint names returned through this, I can then return it, which Swig will then convert into a list of string. So inline says, look at the function signatures. It also says, include this code in the PCB wrap file itself. Let's take a look at that for a minute. So pcbwrap.new is the file that is generated by Swig to create all of the glue code for getting between the Python world and the C++ world. Because this here is an inline block, this code itself is also included in this file here. Here we have this file from C++, which also is then wrapped by one of these things here. And this is what is actually invoked by the Python interpreter. But this thing here calls this after having done some translation from the input Python string object and then also later converting to the PyList. Here we have another inline block with another function. In this case, it's getLogicalLibs. That's the one that gives a list of library names. Again, I need the PCB edit frame. Again, I need the project, fplibtable, and here I simply call the API or the method on fptable that returns getLogicalLibs, and Swig takes care of the rest. So here, this last one that I'll show you is the function footprint info, which will return to you a tuple, actually returns to you a Python dictionary of what's the name of the module, how many pins, what are the keywords, what's the documentation string. So this function returns all of that. This is one of the main ways in which this version of my patch is better and different from the previous version, which I will also show you the bad version. One thing that I kick myself for now is by restricting my thinking to I have the C++ world and I have the Python world, and Swig is the thing that happens in between. I guess I was stuck in thinking that there is a very strong separation between the two, but there doesn't really have to be. So in this case, I have the C++ side of the world. It's inside of footprint.i, but since it's inline, it's really kind of more of the C++ side of the world. Here, I'm doing the same thing I was doing before. I have my PCB edit frame. I get the project, I get the FP list, all that stuff. But then one problem that I came across is that I have this get module info, which returns this footprint info class. This footprint class will disappear when I leave this function. So I can't return a pointer to this thing to the swig side and have translation happen there, because by that point, this will then be an invalid object. So I'll show you how I initially dealt with that while I was still stuck in the separation view of things. But what I ended up doing here, which is I think is much better, is I have this footprint object, and then I directly convert that to Python myself. So here I create a new Python dictionary, and then I set a number of items within that dictionary. So I will set the name item, the lib, the doc, the keywords, in each case, the value from the footprint. And then I simply will return value, which is this Python dictionary. Then when we're here in this footprint info wrapper, it will call footprint info, this guy here, and it simply just returns the result. So here we have result, which is then returned down. So in this case, Swig sees, hey, you're returning a Py object. To convert a Py object, you just return the object. I will show you the bad version of that at the end of this video. Here is pcbnew.i. This is the top level Swig I file. So couple changes that I needed to make here. Here I have autodoc.i, which I'll show in a moment. It is for getting more useful help strings. Here I have Swig type maps. That is for having some automated conversion of C++ types. I'll show that file in a moment as well. Here I have a somewhat obscure but important little section. If your C++ code throws an exception, by default in Kicad, in the pcbnew side of the world, basically what will happen is your program will hang. And it's not even obvious looking in GDB, where did it hang? What I'm telling it here, what I'm telling Swig here is, for this list of functions, there may be an exception and you need to handle it, and whatever the exception string is of that, please return that to the Python world. That's important to know. If you have an exception, if you don't realize there's an exception, you'll simply get a hanging pcbnew and you'll wonder why. I basically stumbled on this, but I'm happy that I did. All right, so here we have pcbnew scripting helpers. Much of what is exposed in the Python interface to pcbnew is based on classes. But there are also a handful of functions that are just functions on the pcbnew module. One really important one that any Python developer for Kicad will come across is getBoard. There's a number of other ones for loading board, for saving board. That's especially useful if you want to have offline scripts for perhaps for panelization, things like that. In this case, the change that I made is the ability for other Swig code to be able to get to the PCB edit frame. So this file here has a local variable called PCB edit frame. A number of the functions in this file needed this, and to do the footprint stuff, I needed that as well. So that's the only small change that I made in here. Here I have the header file. Here I am simply exposing it to the C++ world. In this case, because I have this if endif Swig, it is not part of the Swig world, so you will not see this from the Python shell window. On the one hand, it could be useful to expose this thing to Python, but PCB edit frame has many methods, and many of them, it really would not be good to have them be exposed in Python. So instead, case-by-case basis is how that is being. So that's the end of the modified files. I also have the two new files that I've added. The first of those is autodoc.i. Autodoc is a new file that I've added to take advantage of the autodoc feature of Swig. This is a file that is read by Swig. It takes the name of a function and you give it the string that should be given when you are in the command shell. It's the doc string in the Python terminal. By default, what Swig will do is say, hey, you've got a function called footprints_inlib, and it takes a string and returns a list of strings. That's partially helpful, but in this case here, I like to give an example of this is how you might actually call this function. In the case of footprints_inlib, it's fairly obvious. In the case here of footprint info, it's important to know that the input string needs a certain format. So in this case here, tells you that the colon delimiter is important. And here is a sample of how you might call this and the output that you might get if you were to call it in this way. So if you're just learning use this function, then this doc string I think is much more helpful. One's here. Here we have Swig type maps. The type maps in Swig are custom recipes that you tell Swig, this is how you convert this particular class, C++ class or C++ structure into something else. So in this case, I'm simply telling it to use the Swig standard vector feature, and for a vector of WX string, I want you to go ahead and use the vector template translation on it. Swig already knew how to do WX string. Swig already knows how to convert WX string into a Python string because it was already told how in a different file. So that's a walkthrough of the changes that I needed to make in order to expose the enumeration of footprint libraries as well as footprints within a particular library. I hope that was helpful. If you're interested in the bad version of how I implemented this, that's what I'll talk about next. Now I'd like to talk about my first version of these footprint APIs. This is definitely an inferior way of implementing it. I do not recommend doing it this way. Sadly, I did submit this patch to the Kicad group, and rightfully they rejected it. And once I got my head together and I did some more thinking, I found a much better way of doing it that I already showed you. But let me show you the two mistakes that I made in this implementation. So first, in existing pcbnew, there already is a function that will load a footprint library from a path and then give you the footprints that are in that library. That one is called footprint enumerate. And what I tried to do here is to merge that version with the new stuff that I wanted. So I created this footprint enumerate, takes the library name or path name. Inside of there, I'll take the library name and I'll see, well, does this exist as a directory? If so, then I go in here and I'll do this plugin thing. One thing to note here is that a plugin in the context of Kicad is a file importer. So, I mean, there's a lot of other reasons that you could use the word plugin, a lot of other definitions. But here, in all of the Kicad code that I've seen, plugin really means file import. So importing Eagle is done with a plugin, and loading footprint libraries is also done with a plugin. So what the old code here did is it says, well, here I've got a path name. See if you can guess which plugin I need to actually load this type. It'll give me back a guess type, which I then find. It gives me a pointer to a plugin, and from there I can then do footprint enumerate. So this is what the old version of the API does. Down here is my new stuff to add to that. So the problem with this is that when you look at this code, you've kind of got this mishmash of stuff that is plugin type stuff, which is separate from just asking pcbnew. This was fairly confusing to the people on the Kicad team that were wanting to then merge this change, or at least review this change, hopefully to merge. And it's really just not clear as to the separation. So in the end, what I did is I left the old version as it is, and I just created a new API that in this case doesn't do anything with loading from libraries. It just says, here's the library name, here's the footprints that are inside. So that is probably the smaller of the two mistakes. The second of the mistakes actually is in how I dealt with this, with the footprint info instance here, which will then disappear. This is here first I get a unique pointer to a footprint list. That footprint list, I then ask it for the module info to get this footprint instance. I can't return it. So what I did is I created a wrapper helper class that basically just copies all of the relevant information in it so that I can return that. So here I am returning a constructed footprint info helper thing. So let's look at that file, where the implementation of that is. So here I have the implementation in my swig typemaps.i file. So this is simply code that only lives in the C++ world. It is not a %inline block. Here it's just a struct. It takes a footprint info object and it copies each of the nicknames, docs, keywords, and all that stuff into a local string. And then later on here, I have a type map that says to swig, hey, when you get a swig helper class footprint info thing, create a dictionary, set the things within it to these values, and then return that. So this is 2 extra steps that is just asking for bugs. Here I have a class that all it's doing is it's just copying information. Then here, this thing here is just copying that information out of that copy and putting it into the Python world. When I compare that to my final implementation where in footprint.i, I have a footprint info class and I just do this. All this code here is places where I could have bugs. So the version that I showed you at the beginning of this video, I think is much better. So either way, that is the 2 learnings of those 2 changes. 2 things to avoid, things not to do. I hope it was helpful. I plan on doing some other walkthrough type videos. Please let me know if this is helpful at all. I would like to see more people doing Python changes in Kicad. I would like to see more people submitting changes to the Kicad Python API to make it a richer environment. All right, until next time, see you soon.